Welcome to The Explainer. I am so thrilled you're here today because, well, we're going to demystify one of the absolutely most crucial blueprints of the entire internet. If you've ever looked at a massive, complex network and wondered how it actually stays up and running without just collapsing into total chaos, you are definitely in the right place. Today, we're unlocking SNMP. We're going to visually break down exactly how this universal network translator keeps our digital world communicating seamlessly. Okay, let's dive into this. Picture any modern enterprise environment. You're dealing with a massive, chaotic, heterogeneous network. You've got routers, switches, servers, and they are all from completely different brands. Cisco, Juniper, HP, you name it. Out of the box, these devices are essentially isolated. They each speak their own proprietary language. Trying to manage them individually? Yeah, that's an absolute nightmare. But then, SNMP arrives. It acts like this massive unifying umbrella, giving administrators a single central point to view the status and tweak settings across the entire board. There's a quote I absolutely love because it just hits the nail on the head here. It says, SNMP is the common language between administrators and devices, using standardized tree numbering to manage different brands under one system. It's brilliant. It literally does not matter who manufactured the hardware. If it speaks this common language, we can manage it. It is the ultimate universal translator. So here is our roadmap for today's explainer. 1. Universal language of networks. 2. The 3 core pillars. 3. Translating data with MIB. 4. Polling versus emergency alerts. And 5. Evolution to absolute security. Section 1. Universal language of networks. Section 2. The 3 core pillars. To really understand how SNMP pulls off this incredible feat of translation, we've got to break it down into 3 logical pieces. Whenever you're working with SNMP, keep these 3 mental checkpoints in mind. First, the actors, like who is sending the commands and who is responding. Second, the data. How is the information actually labeled and stored so everyone understands what's being said? And third, the mechanisms. How do these devices communicate efficiently over the network wires? Who, what, and how? Simple as that. Let's look at the who first. It's very much a two-way street, kind of like a commander and a scout. Playing the role of the commander, we have the NMS, or Network Management Station. This is usually a server running monitoring software. Think Zabbix, PRTG, or SolarWinds. It's completely in charge. It sends out the requests. Now, acting as our scout is the agent. This is a little software module actually running inside your managed device, like a router. The agent's sole job is to hang out, collect raw data, like CPU usage or interface traffic, and wait for the commander to ask for it. Section 3. Translating data with MIB. All right, so we have our commander and our scout, but how do they actually understand the data they're tossing back and forth? This is where the translation process happens, and it's so elegant. It's a linear 3-step journey. Step 1, the device data is tied to an OID, an object identifier. This is literally just a long, highly structured string of numbers. Step 2, that number gets pushed through a MIB, the management information base. You can basically think of this as a translator. And step 3, the output becomes plain, human-readable text. It goes right from raw, confusing digits to actionable intelligence. Check this out. Take that ridiculously long string of numbers. 1.3, 0.6, 0.1, 0.2, 0.1, 0.1, 0.1. That is an OID. To you and me, it's total gibberish, right? But when the NMS feeds that exact number into the MIB dictionary, it instantly translates it into system description. The MIB acts exactly like a physical dictionary, giving those arbitrary numbers actual meaning. That way you, the administrator, know exactly what piece of hardware data you're actually looking at. Section 4. Polling versus emergency alerts. Now that we know who's talking and how they understand the data, let's shift over to the mechanisms actually powering this communication across the network. What's really fascinating here is how SNMP chooses to travel. See, most reliable web traffic uses TCP, which involves this heavy, tedious, 3-way handshake just to say hello. But SNMP, it doesn't have time for that. It has to be incredibly lightweight so it doesn't bog down the very network it's monitoring. So it bypasses TCP entirely and uses UDP instead. It shoots these ultra-fast data packets through port 161 for routine queries and port 162 specifically for emergency notifications. No bloated handshakes, just pure speed. For routine checks, what we call polling, the NMS uses some very specific commands to actively pull information. It's basically a checklist. It sends a GET request to ask for one specific OID value. If it needs to read through a whole table of data, it uses a GetNext request to just step right down the list. And crucially, if the commander needs to actually change a setting, say shutting down a compromised port, it issues a SET request. The NMS is constantly initiating these conversations to make sure your dashboard is completely up to date. But what happens when things go sideways between those routine polls? What if a power supply just fails instantly? The Scout doesn't wait around to be asked. It proactively pushes an alert. We've got two types of these reactive alerts. First up is a trap. Traps are these blazing fast, fire and forget messages. The agent sends it and honestly doesn't care if the NMS actually received it. Super fast, but pretty unreliable. The second type is an inform. Informs are slightly slower, and that's because they require the NMS to reply with an acknowledgement. If the agent doesn't get that message received receipt, it's going to resend the alert. So you sacrifice a tiny bit of speed, but you gain high reliability. Now, as networks grew, pulling data one line at a time became a massive bottleneck. Imagine sending a request, waiting, getting one tiny piece of data, sending another request. The round-trip times were terrible. Then, SNMP introduced a real game changer, Get Bulk. Get Bulk allows the NMS to basically say, hey, give me absolutely everything in this massive block of data all at once. It completely revolutionized the system for big data. It drastically reduced network overhead and just skyrocketed transmission efficiency. Section 5. Evolution to absolute security. Speed and efficiency are amazing, but let's be real, in today's world, they mean absolutely nothing without protection. Looking at the security evolution of this protocol, version 1 was the foundation, but its security was incredibly weak. It used a community string, which was essentially just a plain text password floating naked across the network. Then came version 2C, which gave us that awesome get bulk optimization we just talked about. But unfortunately, security kind of stagnated. It still relied on plain text passwords. Finally, we arrived at the modern mainstream standard, version 3. Version 3 brings absolute security to the table. It supports robust authentication to verify exactly who is requesting data and strict privacy through encryption. It guarantees your network metrics can't be eavesdropped on or tampered with. When we bring all of these pieces together, it forms this perfect, seamless management loop. On one track, you got the NMS routinely pulling the agent over UDP port 161, constantly translating those OIDs through the MIB dictionary to keep your dashboard nice and green. But running parallel to that, on the second track, the agent is constantly watching its own hardware. The exact second it detects a failure, it breaks the routine and instantly pushes a trap alert over UDP port 162. So you have routine polling combined with instant emergency reporting. It creates a flawless cross-dimensional closed loop of network awareness. So here is the absolute crucial takeaway. Regardless of how much hardware iterates and changes over time, SNMP's genius lies in its strict division of roles, its structurally organized data dictionaries, and its incredibly lightweight communication. It takes a literal nightmare of messy, heterogeneous hardware and weaves it into a clean, highly visible, and perfectly controllable standard blueprint. And that leaves us with a pretty fascinating thought to wrap up on. Right now, this umbrella protects enterprise servers and routers. But as our networks rapidly expand to include literally billions of new, wildly diverse Internet of Things devices, I'm talking everything from smart factory sensors to connected vehicles, how will these three core management pillars need to evolve to handle that next massive frontier of network chaos? I mean, just try to wrap your head around the sheer scale of the MIB dictionaries alone. It's wild to think about. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will see you next time.